Normal ideas about time, about distance, and, permanence.
We have to. We're sort of drifting out into this silent, endless expanse.
Exactly. We're heading toward an object that just exists on a completely different temporal plane.
And this is where we have to discard the clock. I mean, in this region of the cosmos, time doesn't really pick. It stretches and it folds.
It's not a rigid timeline.
Not at all. It's more like a soft fabric,
Yeah.
immensely deep and profoundly slow. We are entering the realm of the nebula.
And our destination is one of these cosmic clouds, this vast collection of gas and dust and light just suspended for millions and millions of years.
Right.
But we are setting aside the calculators and the light year measurements for a moment. Our mission tonight is not, cold scientific observation. It's pure immersion.
I love that.
We're going to observe the nebula as a painter would, or maybe as a poet. We're going to try to feel it, breathe it, and just drift within it. We want to understand the surprising insights that are hidden in its slow, deliberate choreography.
It's really an exercise in scaling perception, isn't it? We're looking for those deep aha moments that come up when we stop trying to quantify the universe and instead just appreciate the sheer, staggering art of it all.
Of cosmic creation, yeah.
We want to understand the life of a nebula, but on its own terms.
Exactly. So let's set the scene. Imagine you're there now. You're surrounded by this infinite darkness.
The void is it's absolute.
It is. And it's punctuated only by these distant, sharp pinpricks of light stars that are, completely separate from where we are now. And then the nebula itself comes into view.
And the immediate perception is just pure, overwhelming color.
Yes.
And it's not just color, is it? It's color with a texture and a depth that
Go on.
defies any immediate comparison to anything we have on Earth.
What are we talking about specifically?
We're talking about deep, almost regal purples that are swirling, seamlessly with these soft, impossibly gentle pinks.
And these aren't just patches of color.
Oh, no. They exist in these great translucent sheets,
Yeah.
like veils of light, so delicate they seem almost unreal. They're right there at the edge of your perception.
And the thing that pulls the whole scene together, what catches the light and just immediately centers your imagination, is the gold dust.
Ah, the gold dust, yes.
These tiny flecks, what are they, carbonaceous grains?
Yeah.
Silicates?
Yeah, heavier elements forged in previous generations of stars, and they're just catching these stray photons.
And they're glimmering like embers scattered in this dark ocean of the void. It's the perfect contrast, right? The infinite darkness and then these quiet, persistent, glittering sparks.
And that gold dust is so critical because it establishes the temporal context right away, even if we don't realize it at first.
How so?
Well, the nebula moves, of course, but it doesn't have anything remotely resembling urgency. There is no rush in this cosmic choreography. The gas just drifts in these silent, immense waves.
And the rhythm is, it's subtle, deep, but you can feel that it's profoundly alive.
Exactly. Profoundly alive.
And that's really the core paradox we're diving into tonight. How can something that seems so still, something that we have to measure in millions of years, also be so intensely and profoundly alive?
It's a fantastic question.
We need to keep that right at the forefront as we start to examine the structural characteristics, what the sources call the painterly clouds and veils.
Let's do it.
Okay, so now let's really focus our gaze. Let's direct our attention to the physical structures inside the gas. They're not just shapeless blobs, right? They take on these distinct forms.
Yes, and they suggest that there are these immense but incredibly gentle forces at work.
So if you look closer, you see what the sources describe as these soft, pillow-like clouds.
They're magnificent, they're rounded and pliant, and they seem to be puffing gently outward. They appear to be resting under this conceptual weight of 1,000 invisible stars.
One of the sources called it the closest thing the cosmos has to true cosmic upholstery.
That's a great line. They look so inviting, almost tactile.
That is a beautiful metaphor, but I have to push back on that tactile idea just a bit. If it's upholstery, that sounds solid, heavy.
Sure.
How do we reconcile that soft, rounded, almost full description with the scientific fact that these pillows are incredibly diffuse? They're almost a perfect vacuum, aren't they?
That's an excellent point, and that's the beauty of the vast scale. What looks like a dense, puffy pillow to us, something maybe the size of our entire solar system or even larger,
Right.
is still vastly less dense than the best vacuum we can create in a lab on Earth. The reason they look dense and rounded is precisely because they are just slightly more concentrated than the surrounding void. These pillows are density fluctuations. They're areas where gravity has begun to gather the hydrogen and helium just a tiny bit more effectively.
So they're the initial soft stages of gravitational collapse.
Exactly.
So the cushion isn't solid mass at all. It's the visual effect created by the relative concentration of matter in a near void.
Got it. But then contrasting with these dense, relatively speaking, pillows, we have the structures called the veils.
And these are different entirely. They're translucent, whisper-thin sheets of light that flow across the darkness, like sheer silk draped across a stage.
And what are they made of?
The veils are often composed of highly ionized, very hot hydrogen, what we call HII regions. There are these expansive, low-density sheets being heated and shaped by powerful radiation.
Radiation from where?
From young, hot, usually massive O-type stars that are buried within or near the cloud itself. So the contrast between the dense, puffy, slightly colder pillows and then these sheer, ethereal, hotter veils, that defines the texture of this whole scene.
It does. The pillows are where matter is gathering. The veils are where light is winning, spreading matter out and exciting the atoms so much that they actually glow.
Precisely. And if we look at this cosmic canvas as a whole, the blending and the flow of the light and matter, that's where the artistry really comes alive.
You notice how the colors just blend seamlessly? The purples seep into the pinks, and then those pinks flare outwards into gold. And this isn't random at all.
The sources focus a lot on the edges, and I think this detail is absolutely fascinating. They describe the edges as glowing as if they were painted with a trembling brush.
It's a perfect description.
Why is that specific description so potent, do you think?
Because it reveals the true, staggering scale and the impossibility of true perfection in the cosmos. I mean, on Earth, we can draw a sharp line. When you're dealing with boundaries that might be hundreds of light years long, exposed to all these variable pressures and radiation fields and magnetic forces, nothing is a crisp, clean line.
So the edge is diffuse.
It's diffuse, it's imperfect, blurring the boundaries between the gas, the dust, and the void. The trembling brush emphasizes that these edges are constantly being acted upon by turbulent forces, even if it's on an extremely slow timescale.
So the imperfection is the perfection of the scale. The universe has to operate in these broad, sweeping strokes because it's just too vast for tiny details.
And that ties directly into what the source says, that the nebula is a canvas no hand will ever finish.
It's not a snapshot.
No, it's a continuous unfolding masterpiece. The medium is the process. If the universe could draw a perfect line, it would imply a kind of finality,
Well,
But nebulae are defined by their instability and their continuous evolution.
and we have to remember that within these folds, inside the soft material of the pillows and the sheer texture of the veils, the grand narrative of creation is still unfolding. This is our connection point to the future.
It is. We know that within these structures, the seeds of stars are waiting.
Unborn flames.
Yes, unborn flames cradled in the soft gas, just waiting for the mass accumulation to reach that critical point. The visual tranquility, it masks this monumental potential energy.
It's a stellar nursery.
It's the ultimate stellar nursery. The pillows are getting denser, warmer, and more centralized. This is how the cycle of the cosmos works. It's immense patience leading up to these births of spectacular but inevitable energy.
And a single gravitational fluctuation or nearby shockwave could ignite these seeds.
It could, but the sources make it very clear that this ignition might not happen for millions of years from now.
And that brings us back to the sensory detail, the feeling of being here. If we could actually stretch our hand out toward it, we'd feel nothing, right? Because we're in a near-perfect vacuum.
Right, absolutely nothing.
But if you could sense the light, the energy, and the sheer, almost crushing patience of it all,
Yeah.
you'd be incredibly humbled.
The contrast is everything. The visual element is so gentle and inviting. You have pillows and silk, but the conceptual weight of it is just dizzying.
We're talking about a scale of time and space that should feel overwhelming.
And yet, the appearance is one of profound, utter calm. The nebula is power expressed through stillness. It is taking the ultimate long view.
So if the visual structure is defined by these soft forms that contain all this potential, we have to move to the engine that drives the process, the temporal reality. If the pillows are patiently waiting, we need to talk about just how long they've been waiting.
That brings us to time and how radically different the rhythm of the nebula truly is.
Okay, let's unpack this shift in perception. Time in a nebula isn't just slow, it's practically frozen from a human standpoint.
It really is.
The source material gives us these staggering temporal ratios that They feel almost like a joke when you try to apply them to daily life.
They are truly mind-bending. The sources estimate that 1 million years is experienced here as mere minutes. Just think about that. 1 million years is this vast sweep of geological time for us. The rise and fall of ice ages, the slow grinding of continents.
And here, it's the duration of a short coffee break. If the entire history of recorded human civilization, let's say 10,000 years, happened here, it would register as a flicker, barely a second.
Wow. And the physical movement, it matches that scale. The whole concept of motion is redefined when the object you're observing is measured in light years.
Absolutely. A single inch of physical drift for one of these vast clouds is calculated to be an eternity. We measure movement on Earth in miles per second. Here we are talking about movements best measured in, I don't know, fractions of a millimeter per millennium.
It forces us to redefine what fast and slow even mean.
True cosmic motion is not about speed. It's about vastness, interacting with vastness. We see the gold dust glimmering in what are described as these slow arcs. We see the veils of hydrogen fold and shift and stretch.
It's described as the universe tainting a slow-motion masterpiece, where every swirl and every soft pillow of gas is a story written indelibly in patience.
Yes. So let's tackle that concept of patience directly. Philosophically, what does that patience mean? Is it just a consequence of physics, or does it hold some deeper truth about how the universe works?
Well, I think it's a consequence of physics that dictates the deeper truth. In this environment, the timescale for nuclear, chemical, and gravitational reactions is just enormous.
So for a star to form,
For a star to form, the cloud has to overcome its own internal pressure, turbulence, magnetic fields, and that requires a massive accumulation of mass, which, given the low density, takes eons.
so patience, in cosmic terms, means that the outcome is assured regardless of urgency.
That's a perfect way to put it. There's no external clock pushing this creation along. It's a self-contained, self-regulating process that just operates on the necessary timescale.
But the sources really emphasize the lack of drama. There are no sudden fireworks here, no dramatic supernovas, at least not yet, not in this particular quiet, stellar nursery. The focus is entirely on this slow, deliberate choreography. And I find this almost frustrating. If the movement is so imperceptible, how do we know it's moving? Are we sure the data isn't just advanced modeling and we're just projecting life onto what is fundamentally static?
That is an excellent point, and it's where the science really validates the poetic description. We know these nebulae are moving because we have several ways of measuring it, even if the change is glacial.
Okay, like what?
Well, first, we use comparative photography taken over decades. And while a decade is just a blink of an eye in cosmic terms, our most sensitive instruments can detect minute shifts in the positions of dust fronts or the edges of ionization zones.
Okay, so that's one way.
But maybe more compelling is the Doppler shift.
Right, measuring how the light is stretched or compressed.
Exactly. When we analyze the light from the gas, we can measure these microscopic shifts in the spectral lines, and this tells us that different parts of the nebula are moving either slightly toward us or slightly away from us.
And these movements, while slow in our terms, are definitive.
Absolutely definitive. They confirm that the purple cloud is nudging the pink one, the veils are stretching. This imperceptible movement is, in fact, everything.
That makes a lot of sense.
Yeah.
So the movement, even if it's microscopic on a per-second basis, is the evidence of life and change. If it were truly static, it would be inert.
It would be dead.
The fact that the gas drifts over the course of 10,000 years is the pulse of the cosmos. It's the guarantee that the painting is still being worked on.
It's the engine. That microscopic drift is what leads to density accumulation, to gravitational collapse, pressure changes, and eventually stellar birth. It's the movement that matters most because it guarantees the future.
That subtle shimmer you might notice.
Is the grand cosmic engine just turning over?
This brings us back to the relevance for the listener, for you. What does this glacial pace teach us, as inhabitants of a society that demands instantaneous feedback and operates at the speed of deadlines and digital information?
I think it provides the ultimate necessary contrast to the speed of human experience. We judge success and failure based on hourly, daily, or maybe yearly timelines.
If we're lucky.
Right. The nebula demonstrates that the greatest, most profound processes in the universe, the formation of stars, the creation of planets, the generation of heavy elements, they require geological and cosmic scales of time. If we try to apply our human urgency to cosmic processes, we just fundamentally misunderstand them.
It's a call for developing a long-term perspective. The lesson here is that complexity and monumental beauty and true power, They often require monumental patience.
You can't rush the masterpiece.
You really can't.
And maybe on a more personal level, it allows us to appreciate the micro moments of our own existence, the rapid
Yeah.
pace of our lives, while acknowledging that we are set against this backdrop of unimaginable slowness. It's both humbling and, strangely liberating.
How so?
Knowing that our short existence is this burst of speed against the universe's long, slow breath, it gives our rapid lives a certain intensity, a certain preciousness.
I think the most important takeaway from this temporal reality is realizing that those pillows and veils, which look so still to us, are actually accumulating energy so slowly that they pass the point of no return long before we ever saw them.
Yes, we are observing fate in ultra slow motion.
Let's transition now from the invisible force of time to the most immediate impact of the nebula, its color. We're going to focus solely on the specific hues described in the source material, treating them as, well, as deliberate artistic choices by the universe, but grounded in specific atomic physics.
And we have three dominant hues that really define this cosmic canvas. Each one reveals something different about the matter that's present and its energy state. The first is purple.
Described as deep, regal, and almost velvet.
Yes, folding endlessly into the void.
That deep, almost royal purple is so evocative it suggests depth and richness folding into itself, implying this infinite distance and old established matter. But what is the physical source of that regal color?
That specific hue, which is often captured in these long exposure images, usually signifies doubly ionized oxygen O3 or perhaps sulfur S2.
Okay, so when we talk about oxygen in space, it's not the oxygen we breathe.
Not at all. It's an atom that's been stripped of two of its electrons by intense stellar radiation. The resulting emission line, often around 500 nanometers, combines with other ionized elements to create that rich, deep, violet or magenta color palette.
And the velvet quality.
The velvet quality isn't just an illusion. It's the result of light being emitted from atoms that exist deep within the densest parts of the cloud, which gives it that luxurious, rich depth.
So the structural royalty we were talking about earlier, the denser, older parts of the cloud, it has a physical signature that actually matches the metaphor.
It matches perfectly. And then we transition to pink. This is the softer element.
It's described as blushing, gentle, like dawn spilling over the edge of a dream.
Beautiful, isn't it?
It is. If the purple is the backdrop of royalty, the pink feels like the promise of new light, a gentle emergence.
And that softer color is indicative of excited hydrogen gas, specifically the hydrogen alpha emission line. Hydrogen is the most abundant element in the universe, and when intense radiation from a forming star excites a hydrogen electron,
And it falls back to a lower energy state.
it emits a specific red wavelength that, when it's combined with other elements, renders this iconic soft pink or reddish hue. The metaphor of blushing is perfect, because pink is the color of a gentle awakening and massive energy release at the same time.
So it represents the areas of the nebula that are actively being energized by that stellar radiation pressure.
The parts closest to the heat, the parts undergoing the most dramatic change, even if that change is slow.
And finally, we have gold. This is the kinetic element, the one that interrupts and activates the whole scene.
Flecks of sunlight trapped in dust, scattering through the gas, small sparks in an ocean of darkness.
Right.
And the gold is fundamentally different from the purple and the pink. Those two are emission colors light created by the atoms themselves. The gold dust is reflection and scattering.
So it's the solid dust, the silicates and carbon, reflecting the light of distant or nearby stars.
Exactly. Stars that are too far away or too cool to cause the powerful ionization you need for purple or pink. It's the universe using existing stellar light to paint textures into the void.
It's the light catcher. It makes the invisible visible. Now let's analyze the dynamic nature of these static-seeming colors. The sources reinforce this metaphor of the nebula as a living painting.
And this is important. The universe isn't just throwing paint around randomly. There is a cosmic logic to where the colors meet and transition.
And the colors are absolutely not static.
No, they breathe. They melt into one another, illustrating this constant yet imperceptibly slow change. A pillow of deep, regal purple might slowly become a blushing pink over thousands of years.
And that isn't the artist suddenly deciding to change the palette.
No, this is the physical reality of evolving stellar radiation.
Okay, so walk us through the process of that color shift. What would cause a million-year-long slow fade from purple to pink?
Okay, so let's assume a massive hot O star ignites deep within the cloud. Initially, its radiation creates a bubble of high-energy photons, and it intensely ionizes the oxygen and sulfur atoms nearby. That's what results in the deep purple hues.
Right.
But over time, that radiation field expands. As it moves outward, the energy dissipates slightly, and maybe the cloud structure changes, allowing some areas to cool or become less dense.
So the strong O3 lines fade.
They fade, but the basic hydrogen alpha lines, the pink, they may persist over a much wider, more diffuse region. So the color change we'd observe over eons is actually the slow, gradual expansion of a stellar energy wave pushing through the cloud.
It's the ultimate slow fade, dictated by the speed of light and the density of the interstellar medium. And we see this interplay with the gold, too. The veil of gold might drift away, catch new light, and bend it differently.
And that's the structural shift affecting the aesthetic. The gold dust gets driven by stellar winds or magnetic fields, and it moves into a region illuminated by a different type of star, maybe one that's yellower or bluer.
And since the gold is reflecting,
The perceived color of that reflection shifts, illustrating constant, slow transformation. The structure, the movement, and the color are all fundamentally interconnected in this single, immense, silent act of transformation.
this connects the slow rate of change right back to that concept of perceived eternity. When we look at a telescope image, we are seeing a single breath held for thousands of years.
Yes.
We're seeing a brushstroke that took longer than recorded human history to complete. It completely changes how you view that static image.
It should. It should instill this profound respect for cosmic patience. The colors aren't merely decorative. They are a delayed, gorgeous reading of the nebula's complex history and its future potential.
Let's return to the tactile imagery that initially drew us in, that soft, weightless nature of the structures. We have the soft puff of the pillows, so inviting and gentle, and the sheer delicacy of the veils, drifting like silk.
We are invited to imagine running our fingers through the folds of the nebula, which is a beautiful impossibility, of course, but it emphasizes the ethereal nature of the gas.
It's soft, light, almost weightless.
Every crest and trough of gas is described as this gentle undulation in a sea of stillness. This imagery just lulls us into a sense of perfect, profound cosmic tranquility.
It really seems like nothing is happening, just this gentle, silent motion. But this is the crucial point where we have to break that spell of stillness.
We do.
We have to contradict that initial feeling of calm by revealing the profound, hidden energy at work just beneath that soft surface. The stillness is deceptive.
Absolutely. While the surface appears calm, we have to remember that this is a site of creation driven by profound, high-energy physics. The stars will form. That is the inevitable future of these pillows.
And radiation flows constantly.
Invisible, powerful energy shaping and compressing the gas clouds. Gas collides and bends, even if that collision takes 1,000,000 years to register as a structural shift.
This is the paradox of profound life, again. The nebula is described as still, yet it's profoundly alive. Its patience is not passive.
No, it is active waiting. It is the slow, continuous accumulation of mass, of density and heat until that tipping point for nuclear fusion is reached.
So what specific, powerful forces are actively shaping these soft clouds?
Well, the primary force is the radiation pressure from massive, short-lived stars that have already formed deep inside the nebula, those O stars we mentioned earlier. These stars don't just glow, they emit powerful stellar winds.
Which are what, exactly?
Streams of charged particles that blow outwards at thousands of kilometers per second, and they literally carve out cavities inside the nebula.
So those soft, puffy pillows aren't just gently accumulating matter on their own. They are being actively compressed by the shock wave and radiation pressure from their newly formed stellar neighbors.
Precisely. And that compression is what drives the continuing gravitational collapse in the adjacent regions. Another huge force is magnetic fields.
Well,
The interstellar medium is crisscrossed by these magnetic field lines that act like an invisible
so the visual result, this gentle undulation, is the external manifestation of an intense internal conflict. You have gravity pulling inward, radiation and stellar winds pushing outward,
Yeah.
and magnetic fields trying to organize the chaos. And we can see this conflict in the specific light dynamics mentioned in the sources. Notice how the light interacts with the veils. Some parts glow softly, others dim, falling into shadow, or just being too thin to reflect enough light. That contrast creates this dramatic three-dimensionality.
Reinforcing the idea that this is a dynamic interaction of energy and matter.
Yes.
And then you have the golden flecks sparkling in what the source calls quiet rebellion against the darkness. That phrase is so impactful.
It is because it suggests agency in the very smallest components.
Right.
It suggests that even these tiny grains of dust are fighting against the immense gravitational and radiative forces that are trying to disperse them or hide them in the void. They're sparkling because they're catching light from sources that might be hundreds of light years away, and they're holding that light against the overwhelming pressure of darkness. They're persistent particles of heavy elements that survive the birth of the nebula.
And will survive the birth of new stars.
And we're brought back to those edges. The edges of the clouds shimmer like wet paint under a faint sun. That imagery is so critical because wet paint means it's fresh, it's unfinished, and it's still moving.
It implies fluidity and malleability. It tells us that what we are seeing is not a finished, dried piece, but a process that is actively undergoing transformation.
And what's causing that wet paint effect?
It's likely the boundary layer, where the fast stellar winds are crashing into the denser, colder gas, creating a shock front, a boundary that is constantly being deformed and illuminated by the forces of creation. Even if that deformation is measured in geologic eons, the process is active, profound, and unstoppable.
So the nebula is not just seen, it's felt. It is experienced as this soft, endless embrace of time, color, and light. It forces a complete rethinking of what life even means.
It does. It doesn't have to be frantic or fast to be profoundly alive and purposeful.
It's the ultimate lesson in potential energy and necessary conflict.
The quiet grace of the gas folds holds the promise of immense stellar birth. The stillness is temporary, but the life, the transformation is permanent and patient.
So we've drifted through the veils and the pillows, we've wrestled with this profound slowness, and we've appreciated the regal colors and the hidden forces that shape them. Let's try to summarize the core lessons of this deep dive.
It feels like the nebula teaches us these fundamental truths about existence that go far beyond our immediate human experience.
Absolutely.
The primary unifying lessons have to be patience and scale. The nebula just recalibrates our sense of what is fast and what is slow.
It forces us to accept that the most spectacular and meaningful transformations in the universe, the creation of light and life, are often the quietest and the most deliberate.
And we establish those staggering temporal ratios. Millions of years passing like a breath, a single inch traveled by gas feeling eternal, and yet...
And yet, this is how the universe creates. Slowly, deliberately, patiently. This is the master blueprint.
And we have to reiterate that as you imagine these folds of purple and pink and gold, you are witnessing something truly ancient.
Older than recorded civilization, older than the Earth.
Older than human memory itself. It's a vast, slow dance of pillows and veils of light moving across the dark with this quiet, immense grace.
That contrast, the quiet grace against the incomprehensible scale.
Yeah.
That's the final image we have to leave with.
It is.
If we linger in that silence, we can almost feel our own heartbeat, that small, rapid, frantic human rhythm echoing against the vast, slow, patient pulse of the cosmos.
And that internal echo is the key. When you connect your small, immediate rhythm to that vast, patient rhythm, you gain the perspective that your short timeline and your intense energy are just one small, fast wave on an unbelievably slow, patient ocean. The universe has infinite time.
So here's the final challenge, the provocation we want to leave you with. The next time you look up, remember that every faint smudge of light, every cluster of potential energy, it may be a nebula, a slow-motion masterpiece.
It's not just a beautiful picture in a telescope, it's a profound process.
Remember that the life of a nebula is not measured in hours or days.
It is measured in eons, in colors that breathe and shift over millennia, in pillows and veils of light that drift like whispers in space, driven by the pressure of unborn stars.
So take a moment tonight. Let the nebula unfold in your imagination. Feel the patience. Acknowledge the quiet, intense drama hidden just beneath the soft surface, and know that somewhere, in the silent expanse of the universe, a cosmic masterpiece is always being painted. One fluid, inevitable brushstroke every 1,000 years.
Let that colossal patience resonate within you.